Welcome back to a new machine learning tutorial. In this video, we are going to create 3D visualizations from machine learning models. We are going to train decision tree and support vector machine models, and we are going to visualize the decision boundaries of them. Let's start coding. Okay, I'm in the VS Code and I'm going to create a Jupyter notebook, like just say visualize 3D machine learning models.ipmb. And in here, what I'm going to do is I'm going to select my kernel, and let me quickly summarize what we are going to do. We are going to create two machine learning models, a decision tree model and a support vector machine model. We are going to train these models on a data set, and then we are going to visualize their decision boundaries in 3 dimensions. And you can use any code editor that you want, but we are going to be working with a Jupyter file in this tutorial because with Jupyter notebooks we can run code cell by cell, so it's important for seeing the outputs of each code. Okay, let's start. We are going to start by importing the libraries that we are going to be using in this video. So I will import NumPy, I will import pandas, and I'm going to say from scikit-learn.datasets import make classification. We are going to create our datasets with this, and I will say from scikit-learn model selection import train test split. I will say from scikit-learn.tree import decision tree classifier. I will say from scikit-learn support vector machines import support vector classifier. From scikit-learn.preprocessing import standard scalar, and I will say import plotly grab objects as grab objects like this. So let me explain those one by one. Okay, we are going to be using the NumPy for the data manipulation, and we are going to use pandas for the data frames. It works well with the scikit-learn models. We will use scikit-learn make classification for creating our dataset for this tutorial, and we are going to use train test split for splitting our data into training and testing sets. For training the model in the training set and testing it on the testing set, we are going to use decision tree classifier as our decision tree model. We are going to use support vector classifier as our model. We are going to use standard scalar for scaling the data that we have. We don't need scaling for tree-based models, but we need scaling for linear models like support vector classifier. And we will use plotly for 3-dimension visualization. Okay, let's create a dataset. So I will say x, y, we will use the make classification method, and I will say number of samples, let's say 400, number of features, let's say 3, number of informative, let's say 3, number of redundant, let's say 0, and number of clusters per class, let's say 1, and I will say class separation 1.2. And here we are going to have our x and y like this. So we have a binary classification problem. And let's create our data frame, like data frame, pandas data frame. I will pass the x and the columns, like let's say age, income, and what else we can say is, let's say spending, score. And I will say data frame target, and it's going to be equal to the y. So after that, we are going to have our data set ready. I will say data frame.head, and we are ready to go. You can use the same codes for creating a data set similar to mine. And now we will split and scale the data. So let's start. I will say xtrain, xtest, ytrain, ytest is going to be train test split. I will say xy, and test size 0.3, which means that 30% of the data is going to be in the testing set and 7% is going to be in the training set. And after that, I will say scalar is going to be standard scalar. And next up, we are going to scale the training and testing set separately, like xtrain scaled is going to be scalar fit transform and xtrain. And for the xtest, what we are going to do is we will just use transform method. We are not going to train it. So xtest scaled is going to be scalar transform x test like this. Again, we are not using fit in this one. Now let's train two models, a decision tree classifier and a support vector machine with an RBF kernel. But what I'm going to do is I'm just going to give random parameters. I'm not going to do like parameter tuning or something else. This tutorial is only for three-dimensional visualization. I have a machine learning tutorials playlist on the channel which have more than like 50 videos. You can just watch it for learning train test split, scalar, or even parameter tuning from there. I have video for all of those. Okay, let's continue with the decision tree model. I will say decision tree classifier, and after initializing it, let's say max depth 5, and it's enough. Let's not give anything else. And SVM model, it's going to be support vector classifier, kernel is going to be RBF, and I will say probability is going to be true, and I'm going to give the gamma like auto, and we are going to be ready to go. Now let's train our models. For the decision tree model, I will say fit, x train scaled, and y train. And for the support vector machines model, I will say fit, x train scaled again, and y train again. So we have our models ready right now. Now we are going to be creating three-dimensional mesh grid or feature values and using our models to predict probabilities across that grid. Then we are going to visualize that predictions using plotlist three-dimensional surface plots. So let's start with creating a three-dimensional grid of the x range points. So x range is going to be numpy in space x train scaled, and I will take like the 0 in here and I will take the minimum. And next what I'm going to do is I will say x train scaled, I will take the 0 dot maximum, and I'm going to take the 30 like this. So for the y and z we are going to do the same, but let me quickly copy and paste those. What we are going to change in here is for the y, let's change its name. We will say 1 in here and also 1 in here. And for the z, what we are going to do is we will say 2 in here and 2 in here. So let's make those run like this, and we are going to be ready to go. Okay, now we are going to create the mesh grid. So xx, yy, and zz is going to be numpy mesh grid, x range, y range, and z range that we defined in here like this. So I'm going to make this run, and I will say grid points is going to be numpy xx ravel, yy ravel, and zz ravel. Okay, now we are going to predict the probabilities for class 1 in both models, decision tree and support vector machines. So decision tree probabilities is going to be decision tree model that predict grid points, and we will say for the class 1. So we are going to have something like this. Okay, now I will say support vector machines probabilities is going to be support vector machines model predict probability grid points, and I will say one like this. So we are going to have something like this in here. Each of these points represents a position in our three-dimensional feature space, and we now have predicted probabilities in here for both models. Okay, now we are going to plot them. We are going to start with decision tree. So I will say figure decision tree, and I will say graph objects figure, and let's go like data, and we will pass x is going to be x train scaled, and we will say 0 like this. Y is going to be x train scaled, and we will pass the 1, and z is going to be x train scaled, and in here as expected we will pass 2. Mode is going to be markers, and marker is going to be dictionary of size 4, color white train, and I want to give a cover scale. Like what we can give in here is, let's go with, actually let me fix the typo where it is like this. Okay, I'm going to continue with the name training points, and next up I will say, actually after data I need to pass like grab objects, scatter, 3 dimension, and after that actually I need to put closing parentheses in here, and I'm going to continue from here. Like I will say grab objects volume, and in here I will say x is going to be xx flatten, y is going to be yy flatten, z dot flatten like this. Value is going to be decision tree probabilities, and I will say 0.5, and next I will say ISO max, and it's going to be 0.5. Opacity is going to be 0.2. You can change these numbers and see how the plot changes. I'm just going to give random numbers for showing you. 1, and let's add the color scale like blues, and actually not like that, blues like this, and name I will say decision boundary. So we are going to have this ready, but these are red. Let me fix this up. In here I will say closing bracket and parentheses, and I think if we change this, everything is going to be working smoothly. Yeah, just like expected. Okay, now we are going to update the layout like figure decision tree, update layout, and I will say title is going to be decision tree decision boundary, and the scene is going to be dictionary, x-axis title is going to be age, y-axis title is going to be income, and the last one is going to be spending score. And now what we are going to say in here is, we will say, like, let me go out of this parentheses, figure decision tree dot show. So it's going to say loading, and here it is. So we have our 3-dimensional plots ready in here. We firstly say grab objects figure and scatter 3 dimensions, and we define the parameters like this. Then we call the volume from grab objects, and we gave the decision boundary code, and after updating the layout we have our plot ready, and let's check it. So firstly, the plots in Plotly is interactive, so I'm just going to click and just change the view of this. Like you can just move your cursor into a plot for seeing different values inside here, and at the right tab you have options like, let's go one by one on there. We have reset camera to last save, reset camera to default, turnable rotation, like I'm just going to click on that for showing you, and now I'm going to click on that again. So here we have this, and we have the orbital rotation. I'm clicking on that, and we are going to see that we are going to be changing like this, and I'm going to reset camera to the default, and we have the pen for moving like this, and we have the zoom feature for getting closer to the plot, and after that we can take the pen, or we can take the orbital rotation for seeing from the different sides the predictions like this, and also we have the download plot as a PNG option. Like I'm just going to reset camera to default, and we can check it like firstly taking the zoom and getting closer, and we can take the orbital rotation like this, and we can see that it forms these sharp boxy partitions that's typical of trees. Okay, let's now see the support vector machines plot. So I'm just going to create that in the similar way, like I'm just going to say figure support vector machines, and I will say grab objects figure, and I will pass the data like grab objects, scatter 3 dimension, and for the x we will give x train scaled 0. And by the way, I also want to mention that since we are using synthetic data, the values are like too smooth to be in the real life, but when you are using a real data set, you are going to be seeing the differences. Like this stuff is going to be giving you more insights from your data. Right now only we can see 3 purple dots in the yellow area and nothing much since it's synthetic, but we are going to see the support vector machines right now. Like y is going to be x train scaled, I will give 1, and next up we are going to say x train scaled, and I will pass like 2 in here. Mode is going to be markers, marker is going to be dictionary, size 4, color y train, and color scale. Where this again, and let's give the name again training points like this, and let me also put command there, and again we will say grab objects volume, and again x is going to be xx flatten, y flatten, and we will say z flatten. Value is going to be support vector machine probabilities, and isomin is going to be 0.5, isomax is going to be 0.5, opacity is going to be 0.2, surface count is going to be 1, color scale, let's say red, and name is going to be decision boundary again. And after that I will say figure support vector machines update layout, and I will say title support vector machines decision boundary, and scene is going to be dictionary, x-axis title, age, y-axis title, income, and z-axis title is going to be spending score like this. And we can say directly figure support vector machines dot show. So actually I think I have a problem. Yeah, I think I have a typo in the cover scale. Yeah, here I say cover scaled, so I'm going to fix that, and I think yeah, we are going to be ready to go. Here we can see that we have a much smoother curved boundary, so let me quickly zoom into that. Like you can see in here, it's not like direct, and let me take the orbital rotation in here. Like you can see, curved boundary makes sense because it uses kernels to capture nonlinear relationships. Awesome. And since we didn't specify like anything for random state, when we say run all for all the code, we are going to see different type of data and different type of visualizations like this. You can try with different data sets. Like I'm going to say run all again, and we are going to have different 3D plot every time when I run this like that. And that was all for our coding tutorial. Don't forget to try this with your own datasets. Thanks for watching, and let's get to the outro. Thanks for watching this machine learning tutorial. I'm sharing new data science videos every week on my channel. You can subscribe for more videos like this. Also, I have a machine learning tutorials playlist where I have more than 50 videos just like this one. You can reach that playlist from the cards of this video or from the links in the description. Have a great day.